Hello guys, welcome to Solving Solutions on Bound channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to look at some fundamental concepts in surveying. Now, we have been able to establish over time that our delta nothings and our delta eastings are, or let's say our delta eastings and our delta nothings are L sine theta and then L cos theta, right? Good. And then we have also known that the distance, I think this was far back even before we started surveying, that distance is equal to the square root of your delta nothing squared plus your delta easting squared. However, we did not use delta nothings and delta eastings as early as when we knew it, right? Good. So, and then we have a bearing to be tan inverse of delta easting over delta nothing. So how did we come by all of these formulae? So that's what we are trying to show to you on today's tutorial. So we have the four cardinal points. We have the north, the south, the west, and the east, right? Good. So when you have your four cardinal points here, you can have a direction at any of the quadrants, right? Good. So your direction can come from here to this point. Your direction can be in this quadrant, it can be in the third quadrant, or it can be in the fourth quadrant, right? Good. So that's if you're going in this clockwise direction, right? Good. So it can be in the first, the second, the third, or the fourth quadrant. Now when it is in the first quadrant rather, we believe or we know that it is coming from the north. Therefore, if you have a 40 degrees here, you can see it as north 40 degrees east, right? Good. Or you can just call it 40 degrees directly, right? Good. So if you want to use the whole circle bearing or the quadrantal bearing to denote your direction. Similarly, if you have something like 40 degrees here, you can say south 40 degrees east, right? Good. However, if you're now coming from the true north, it will now be 90 and then maybe 40, which should be about maybe 130 or thereabout. So that's about changing the quadrantal bearing to the whole circle bearing. So these are some fundamental concepts. Now let us stick to what we have. We have about a 40 degrees bearing from a distance OA, right? Good. So we now said, okay, if we know that this line is OA and then that is our length, and then we have a bearing of 40 degrees that helped us to what, to define that line, then we can see we can draw a line from the north down to where it intersects that direction line, and then we can also draw a line from that distance line to where it intersects the north, or the east rather, or from the east to where it intersects what, the line, right? Good. So what we are trying to achieve here is simply rise over run, right? Something like that, because you know, if you move from O to E, whatever you are having is your easting. If you move from O to your N, whatever you're having is what, your northern, right? Good. So if you have a line here and then you have moved this direction, and then it is at this point that it intersects this line, which means your first easting is here and then your second easting is here. Therefore, for you to have the value of this easting, it will be the easting of this second point minus what, the easting of this first point. I hope we remember how we used to do it in graph, right? Good. So similarly, if you now come to this point, which is for your nothings line, your first nothing is here, which is the origin, and then when you move because of this line, you get to another nothing, right? Good. So if you find the difference between your second nothing and your first nothing, you are going to have what, your delta nothings. Are we together? Good. So if we have been able to establish that fact as well, we can now decide to extract this right angle triangle where the 40 degrees is what is subtended. So if we bring it out, if we extract it out rather, there should be a C here, right? Good. So we now have a right angle triangle AOC, which is A, O, and C, right? Good. So that's this right angle triangle you've seen here. So it then means that, you know, what we have here is equal to what we have here, and then what we have here is also equal to what we have here, right? Good. So these are some fundamental stuff. So if that is the case, and then we have our right angle triangle here, which means there is a 90 degree denotation here, right? Good. So It means this is our delta easting because we have been able to establish that the difference between your first easting and then your second easting will give you a delta easting. Similarly, the second and then the first will also give what your delta nothings on the what on the nothings line, right? Good. So if that is the case, we can also say what this is what our delta nothings. So if we label it correctly, we have what the CAO or maybe OAC or whatever we want to call it. So from here we can use what SOHCAHTOA, right? Good. Now this SOHCAHTOA is also another fundamental trigonometric concept, basic trigonometric concept, right? Good. So if we say let's use SOHCAHTOA from the triangle AOC, so we now see that so is what the sine of the sine, which is opposite hypotenuse, then the car is cosine, which is adjacent hypotenuse, and then the tan is what opposite adjacent, right? Good. So that is what we have written down here. So if we now try to apply it to our right angle triangle, the opposite is always what the side that is opposite the angle. That's a very simple way to remember what the opposite is, right? Good. So if we have the angle to be 40 here, in our case it was a bearing, but let's still call it an angle now. So if we have our angle to be the 40 here, and then we have this side that is opposite the angle, so this side automatically becomes what the opposite, and then the line on which it lies is what the adjacent, right? Good. And then we know that the hypotenuse is actually what the longest side of a right angle triangle, right? Good. That joins our opposite and then our adjacent, right? Good. So that's how we have the O to be opposite, the A to be adjacent, and then the H to be what the hypotenuse. So if we now denote it correctly, which means that our O is what our delta eastings, we have established it from the beginning, right? Good. Because we told you that this side is equal to this side, and then this side is also equal to this side, right? Good. So we have been able to establish that our O is our delta eastings, and then our A is what our delta nothings, right? Good. And then this L, or which is the distance, is now what the hypotenuse, right? Good. So our hypotenuse is what our distance, right? Good. So if we now try to spell out what sine theta is, so sine theta is equal to what opposite over hypotenuse, right? Good. And then that is equal to, we have established that our opposite is what delta eastings, which is this, divided by the hypotenuse, which is what our length, which is this, right? Good. So if we know the angle, which is this, and then we know the length, which is this, right? Good. We can actually calculate what our delta eastings. It now implies that our delta eastings will now be equal to multiplying this by this, multiplying the hypotenuse by what sine theta, and then our hypotenuse is what the length. Therefore the delta easting will now be L sine theta. Please, if you missed it at any point, you can always pause and then rewind, because these things are very, very important, and then they are all linked, right? Good. So they are linked together. So we now have what L sine theta to now help us what calculate delta eastings. So if you now impute the value of L, you have 200, which was provided there, and then sine theta to be 40. So please confirm this value on your calculator, because we are going to use it very soon. Similarly, if you come to cos, because that will now help us to what to get delta nothings. But we missed something. So how did we know that it was sine that we are going to use? We didn't explain that part, right? Good. So now how did we know that it was sine that we are going to use? Now there's a relationship. We have the opposite, the adjacent, and then the hypotenuse, right? Good. And then they are related by SOHCAHTOA, or maybe they are related with SOHCAHTOA. What it means is that if you are going to use sine, that means you must have the angle and the hypotenuse, or the angle and the opposite, or the opposite and the angle. So there must be two parameters that are working with sine that you must have. So in our own case now, we have the opposite. We are looking for the opposite rather, and then we have the hypotenuse and we have the angle. Therefore sine would work, because it is sine that connects what the opposite and the hypotenuse. That is just the fact. Similarly, when you come to cos, we are looking for what delta nothings, right? Good. And what links your adjacent and your hypotenuse is actually what cos, right? Good. So that's why you have cos theta to be adjacent over hypotenuse. So that is the reason why cos is used here, and then sine is also used here, right? Good. So this is what defines the relationship, or this is what shows what the relationship. So if we proceed further, our adjacent, which is what delta nothings, is here, and then the hypotenuse, which is what our L is here, right? Good. So it then means that our delta nothings would simply be L cos theta. So do you now understand how these two fundamental formulae in surveying, or maybe traversing as the case may be, do you now understand how we came by them? Good. So you've seen delta S to be L sin theta, and then you've seen delta nothings to be what? L cos theta, right? Good. So if you further simplify, there will be an answer here that you should write, because we are going to need it very soon. So we have been able to define that our delta S is L sin theta, and then our delta nothings is what? L cos theta. Now, still from that our right angle triangle, we can use the Pythagoras theorem. Now, that's why I say this distance formula is known, because Pythagoras theorem has been known to us from way back, right? Good. So if we want to invoke the Pythagoras theorem here, it simply means that, or it states that, the square of the hypotenuse is equal to the sum of the square of the other sides, right? Good. So we just denoted it with what we have here, which is the h square, which is the hypotenuse square, is equal to the sum of the square of the other sides, and then the other sides are a and o, right? Good. So we have a squared plus o squared, right? Good. So it's actually very simple as that. Therefore, our h will now be, if we don't need the square, we just send it as square root to the other side, right? Good. That means we find the square root of both sides, so the square root and this square will go out, and then we just have h, right? Good. So it now be the square root of what? A squared plus what? O squared. So that is the formula for h, and then this h, as we have told you earlier, is equal to what? Our length, right? Good. Or the distance. So you should recall that our h is what? The length or distance, and then our a, which is the adjacent, is what? Delta nothings, and then our o, which is what? The opposite, is what? Delta distance. Therefore, we can rewrite this equation we have here to be, instead of h equal to the square root of a squared plus o squared, we can now write it, or rewrite it in terms of surveying, to denote L equal to the square root of what? Delta nothing squared plus what? Delta S squared, right? Good. So this is what we use in surveying, right? Good. The delta nothings, which is the difference between the first and the second nothings, and then the delta instance, which is also what? The difference between the first and the second instance, right? Good. Depending on wherever you're going to. So that will help you define your length. Now we can still, or we shall still, reuse our SOHCAHTOA, because this second aspect is when you have been given your delta nothings and your delta instance, and then you want to define what? Your distance and your bearing. However, the first scenario was when you have been given what? Your distance and then your bearing, you want to define what? Your delta instance or your delta nothings. So there will be a check somewhere around there, which will now help us to know if the delta, if the delta instance and the delta nothing that we got from the distance and bearing can still return the distance and bearing, right? Good. So that's the check. So we have been able to, we are now using the SOHCAHTOA to get the bearing, right? Good. So if you look at the bearing actually deals with what? Your instance and then your nothings, right? Good. That's your delta instance and your delta nothings, and then your delta instance and your delta nothings in terms of SOHCAHTOA is what? Your opposite and then the adjacent, respectively. So what is the relationship between opposite and adjacent? Is actually tan, right? Good. Therefore, we are now going to say tan theta to be equal to opposite over adjacent. So what is your opposite? Your opposite is what? Your delta instance. And then what's your adjacent? Your adjacent is what? Your delta nothings, right? Good. So this simply means that if you want to now find the bearing, remember that this is tan theta. Therefore, your bearing will now be equal to the tan inverse, right? Good. So instead of having tan, it will now be what? The tan inverse. It will now be what? The tan inverse of delta instance over delta nothings. I know that you have been using this, but perhaps you wouldn't have thought of knowing or understanding the rudiments, how they came by. So we just thought of doing that on today's tutorial. Therefore, your distance, which has been established earlier, is equal to the square root of your delta nothing squared plus what? Delta instance squared. Similarly, your bearing is now equal to the tan inverse of what? Your delta instance all over your delta nothing. So 1, 2, 3, 4, or let's say 1, 2, 3, 4, are actually core. They are fundamental in our understanding of surveying. Now, a final note. This final note is very crucial. It is extremely important when you are trying to define the bearings of lines using this tan inverse of easting over nothings. Remember, when we started, we told you that your bearing can come from any quadrant, right? Good. So let's now use this. If you are in the first quadrant, it is believed, or it is known, or you can confirm that your delta nothings and your delta eastings are both positive. So that's why you have your nothings to be positive and then your eastings to be positive, right? Because they are all at the up and the right. The positive, the north is actually the top and it's positive, and then the east is what, the right, and it's also what, positive, right? Good. But if you come down to the second quadrant, you would see that it is bounded by what, east and south, right? Good. And south is negative north, therefore your north is what, negative, and then east is still positive, right? Good, because it is still towards what, your right hand. Then if you come down to the third quadrant, you will see that it is bounded by what, west and south, and you know that south is negative north, therefore your north is what, negative, and then west is also what, negative east, therefore what, your easting is what, also negative. Finally, if you come to the fourth quadrant, you see that we are still at the up and then we are on the left. It is bounded by what, the north and the west, right? Good. It means that your north is positive and then your east is what, negative, because it's towards the west, right? Good. So if you have, what this simply means is that if your delta nothing is positive and your delta easting is positive, it's in the first quadrant. If your delta nothing is negative and then your delta easting is positive, it is in the second quadrant. If both delta nothings and delta eastings are negative, they are in the third quadrant. And then if your delta nothing is positive and then your delta easting is negative, it is what, in the first quadrant, in the fourth quadrant rather. Are we together? So this is very important. Now, how does it apply, or what is the implication on the bearing? Its implication on the bearing is that whatever value you are going to have, having used this tan inverse of delta easting over delta nothings, should be subjected to what we have as theta 180 plus theta, 180 plus theta, and then 360 plus theta. And what do all of these mean? It means that in your first quadrant, where your delta nothings and your delta eastings are positive, whatever bearing you are going to have, that is the bearing of that line. You would not do anything to it. When you now come to the second quadrant, when you have your delta nothings to be negative and then your delta eastings to be positive, whatever bearing you are going to get, having used this tan inverse of easting over nothings, you are going to add 180 to that value. When you add 180 to that value, it will now give you the corresponding bearing of that line, which means using tan inverse of delta easting over delta nothing does not sufficiently give you the bearing of a line that is in the second quadrant. So whatever value you have as your bearing, you must add what, 180 to it. So it will be 180 plus that value. Are we together? So if you move to the third quadrant, similarly, when you have your nothings to be negative, that's your delta nothings to be negative, your delta eastings is also negative, and then you have done your tan inverse of easting over nothings. Whatever value you are also going to have as the bearing, you add 180 to it. That will now give you what, the bearing of that line. Are we together? And then finally, when you now come to the fourth quadrant, when your nothings or your delta nothings are positive and then your delta eastings are negative, and then you have used this bearing of tan inverse of easting over nothing, whatever bearing you are going to have, what, you just add what, 360 to it. So that will now give you the bearing of that line, right? Good. All with reference to wherever we are coming from, which is what, our true north, or maybe whatever knot that has been adopted. But basically, we have shown you exhaustively on today's tutorial that you can actually get this, your delta eastings and your delta nothings, on your own when you draw these quadrants, and you can also go further to get your distance and your bearing on your own when you still use what, the four quadrants, right? Good. And then we also let you understand that when you have a bearing using your tan inverse of easting over nothing, that's not the end. You need to subject it to these signs, right? Good. To know which quadrant it falls and to know what further addition or further operation to be performed on that value before ever you get the bearing of that line. Now there's a video on the channel where this particular aspect of today's tutorial was exhaustively explained. We'll leave a link to that video on the description section so that you'll see where we have used different values that fell in the different quadrants. Right, good. And then we have used the bearing formula to solve, and then we have applied what the different additions of 180, 180 and 360. Now we told you about a check. When we started, we said our distance is what? 400. Sorry, is it 400? 200 rather. 200 meters. And then our bearing is what? 40 degrees, right? Good. So when you are having tutorials like this, it's always best you have a calculator by you so that you check whoever is presenting for yourself first of all before ever you actually check for the person that is presenting, so that you would ensure that you are actually deriving the same maybe answer or whatever the case is as the person presenting. So if we were given a distance of 200 meters and a bearing of 40 to start with, and then we got our delta easting to be 128.558, and then our delta nothings should be 153.209, right? Good. So 153.209. So if we use 128.558 alongside 153.209, please confirm this value on your calculator. Are we still going to get a distance of 200 meters and then a bearing of what? 40 degrees as our distance and bearing or from where we came, right? Good. So that is the check. And then having done that, using the formula of square root of delta nothing squared plus delta easting squared, we got our distance. And then using the bearing formula of what? Tan inverse of what? Delta easting over delta nothing, we also got this. But remember, it fell in the first quadrant, therefore we did not add anything to it. It was the bearing as we have gotten it. If it were here, which is the second, the third or the fourth, something would have been done to it. So thanks for coming to class. We hope we have exhaustively shown you the proof. Yeah, we have shown you how to derive some of these formulae, this basic formulae in surveying. So we are going to see you on the next tutorial. Ensure you keep staying safe and have a very good time. Bye.